Hello students, how are you all? I hope you all are doing good. Okay, so welcome back again to the third session of this chapter, Chemical Effects of Current. So we have already done the two lectures in this chapter, and in the last chapter, in the last section, or I can see in the last lecture, what we have learned about the two things. Yeah, one is electroplating. One is electroplating, that is known as the deposition of layer of one metal over the layer of another metal. Okay, so electroplating is due to the chemical effect of current. And what we have also learned about some basic things about domestic circuit, that what actually domestic circuit is, which components domestic circuit consists of. Okay, so we all have learned this in the last lecture. So today what we are going to learn, we are going to learn two new topics basically. We are going to learn two new topics. So let's start what we are going to learn today. Okay, so guys, thumbs up. Yeah, we'll start the session. Okay, yeah. So we are going to start the next lecture of electricity, or this is the last lecture. So today what we are going to learn, we are going to learn two topics. One is Ohm's law. The second one is combination of resistors. Okay. So basically, if you see this diagram, what you are observing, there are some red balls. Okay. There are some red balls, and if you can see this picture, yeah, this is a familiar picture to everyone. This is the cell. In daily life, we call this as a cell, which is used in TV remotes, air conditioner remotes. Yeah, we basically see this. So what this battery or cell do, cell, or you can say battery also. Yeah, along with cell, you can also say battery. So what this cell or battery do, this is providing them a energy, if you can see, or you can see a force. Yeah, this battery is providing these red balls as a force to go in the upward direction. Yeah, to raise it to some height edge. So now what they are doing, they are going round in a circuit like this. Yeah. Now this is a resistor. This zigzag part is the resistors. So balls are moving through these resistors. They are just like bumps on the road. Resistor is just like bump on the road. So whenever you find any bump on the road, it resists your motion. That's why it is known as resistor. Okay. And again, it is coming back to the lower end and again lifting up. So basically a cyclic process is happening place. Basically a cyclic process is happening place. So this difference in height, whatever difference is this height, is known as voltage, or you can say potential difference. Voltage, or you can say potential difference. So voltage or the potential difference is the energy, or you can say force provided by the battery for the movement of these red balls. These red balls are nothing but the electrons. So whenever electron flows in a circuit, it is consisting of a current. Okay. And when current flows through a resistor, what is the resistor property? Resistor has a property to resist the flow of current through that material. So that property which provides the resistance to the flow of current is known as resistance of the conductor. So three things are important in this regarding Ohm's law: resistance, second is potential difference, and the third one is current. So basically, with the start of the first topic, Ohm's law, we are going to relate these three physical quantities. One is resistance, second one is potential difference, and third one is current. Basically, or usually we define resistance with a symbol capital R, potential difference with a symbol capital V, and current with a symbol of capital I. Okay. So basically in Ohm's law, what we are going to see, we are going to see some relation between resistance, potential difference, and current of any conductor. Okay. Now let's move on to what is actually Ohm's law. Getting my point? Okay, guys, ready? So what Ohm's law says, suppose this is a circuit, you can see in the diagram. Okay. This is a conductor. This one is a conductor. So through conductor, current is flowing. And this is a battery basically. Battery is a combination of numerous number of cells. This is first, second, third. So this battery is a combination of three cells. Yes, this battery is a combination of three cells. This conductor is present here, and conductor has some resistance also, which is R. Okay. So what is the experimental data observed during experiment? That whenever you increase the potential difference with the help of battery, suppose you are increasing the number of cells so that you can increase the potential difference or the voltage. So as soon as we increase the potential difference, the current in the circuit was also increased. Yes or no? As soon as you increase the potential difference in the cell or battery, the current in the circuit was also observed to be increased. So here comes the relation that V was directly proportional to I. Because if V is increasing, then I is also increasing. So we can say V is directly proportional to I. Yes or no? Clear? So Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. So what is this saying? That current through the conductor, this is the conductor, suppose I current is flowing through this conductor. So according to Ohm's law, the current through this conductor between 2 points of the conductor, suppose this is A point, this is B point. So the current through the points A and B of any conductor is directly proportional to the voltage, or you can say potential difference, or you can also say potential difference. So it is directly proportional to the potential difference between the 2 points. So suppose this is a conductor. Okay, these are its 2 ends. Suppose the potential difference between these ends is V and current flowing is I. So the current is directly proportional to potential difference between the 2 points of a conductor. So if you have to remove the proportionality constant, you have to put a equal sign. Yes or no? If you want to put a proportionality constant, you have to make a equal sign like this. So when we remove the proportionality constant comes this R. So this R is nothing but the resistance of the conductor. R is nothing but the resistance of this conductor. So basically this was Ohm's law. This was Ohm's law, and what is the final result from the Ohm's law? That potential difference between any 2 points of a conductor is equals to product of current through that conductor and resistance of that conductor. Okay, and I already discussed that resistance is the property of a conductor to resist the flow of current through it. To resist the flow of current through it. That is known as resistance of the conductor. So I think Ohm's law is clear that V equals to IR. And if you can see, V was directly proportional to I, or you can say I was directly proportional to V. So if you want to draw a graph between current and potential difference V, so this is the graph shown here. Current is on the y-axis and potential difference V is on the x-axis. So whenever there is direct proportionality sign, it means the graph is a straight line. Graph for or I can say the graph for a directly proportional relation is always a straight line. So this was the experimental data observed. This was the experimental data observed that the graph between I and V was a straight line. So we can say I is directly proportional to V, or we can say V equals to IR, where R is the resistance of the conductor. This thing is clear? Thumbs up, guys. So this is the basic Ohm's law that gives you the relation between 3 quantities: potential difference, current, and third one is resistance. I hope all these 3 things are clear. Now talking about some units also, what units we use. Units. Okay. First of all, about potential difference. Potential difference. So the symbol we are using for potential difference is V, and the unit, or I can say SI unit of potential difference, is known as volts. Or you can simply give the unit with a symbol capital V. So the symbol for potential difference and the unit are eventually same. Okay. So second one is current. Second quantity is current. Current has a symbol capital I, and it has a unit which is known as ampere. Ampere represented by capital A. So this is the SI unit of current. So what was the third? Third one was the resistance. Third one was the resistance. So resistance is represented by the symbol capital R, and its SI unit is ohm. SI unit is OHM, ohm, and it has a symbol like this. So this symbol is known as omega. Omega is the name of the symbol, and this is actually symbol for ohm. So whenever you want to represent the resistance, you have to represent the resistance in terms of SI unit as ohm. So I think the basic 3 things, potential difference, current, and resistance, are clear. What are their symbols, what are their units, and what is Ohm's law? So Ohm's law is V equals to IR. This is Ohm's law. I think this is clear. Done? Okay. Now next, that this is also important, that factors on which resistance depends. Factors on which resistance depends. So resistance basically depends upon the 3 things. Resistance basically depends upon 3 things. Length of the conductor. Yeah, length of that conductor whose resistance you want to interested in finding. Yeah, length of the conductor. Second is cross-sectional area. Second is cross-sectional area, and third one is the material. Third one is the material of the conductor. The material by which conductor is made up of also affects the resistance of that conductor. Yes or no? So these three things will affect the resistance of conductor, and the relation between these is this one. R equals to rho L by A, where rho is the known as resistivity, L is known as length, and A is known as cross-sectional area of the conductor. Okay, so this is the symbol of showing any resistance. This is the symbol we basically use to represent the resistance. This zigzag line like this. This is resistance R. Okay, so R equals to rho L by A, where rho is resistivity. So basically resistivity is the property of material. Okay, so if any conductor is made up of any type of material, then its resistivity is fixed. What can I say? If a conductor is made up of any particular type of material, then its resistivity is fixed. Yes or no? Because it is the property of the material. Then second is length of the conductor, which is L, and A is the cross-sectional area. So can I say resistance is directly proportional to length? From this relation, you can observe if length increases, resistance will increase. So that means directly proportional. If area of cross-section increases, then resistance will decrease. Yes or no? Because resistance is inversely proportional to cross-sectional area like this. Yes? So if quantity in the denominator increases, the value of the resistance increases. Or vice versa. That if the area of cross-section decreases, the resistance will increase. This is clear? And third one is the rho. Rho is known as resistivity. So resistivity only depends upon the material of which the conductor is made up of. So on these three things, resistance depends. R equals to rho L by A. I hope this is also clear. So we have already done Ohm's law. We have already seen what are the factors on which resistance will depend. Done? Thumbs up guys, all clear? Okay. Yeah. So a question can be asked like this from the topic resistance if I give you. So before that, let's come to the unit of resistivity also. We are talking at the same time. R equals to rho L by A. So rho will be RA by L. So if you want to find the unit of resistivity, can I say unit of resistivity will be resistance into a cross-sectional area divided by length. So what is the SI unit of resistance? It is ohm. We all know SI unit of resistance is ohm. What is the SI unit of cross-sectional area? It is meter square. And what is the SI unit of length? It is measured in meter. So the final answer will be ohm meter. Okay, so the unit of resistivity rho is ohm meter, and it is the property of the material of the conductor. Okay, it is the property of the material of the conductor. Done. So you can write three important points as a note point, that resistance increases with the increase in length of the conductor. The increase in length of the conductor. So this means if the length of the conductor increases, ultimately the resistance of the conductor will also increase. And I already told you it is directly proportional. Yeah, resistance is directly proportional to the length. This is clear. Second point is that resistance decreases with the increase in cross-sectional area. The increase in cross-sectional area of the conductor. I think this point is also clear because it was inversely proportional. If cross-sectional area increases, resistance decreases, and vice versa. Vice versa means if cross-sectional area decreases, resistance will increase. That is known as inverse relation. Okay? Yes? So these are the two important points, and you all know resistance also depends upon the material of the conductor. And which property shows the material of the conductor? That property is the resistivity. So resistivity depends upon the material of the conductor. So I think this is clear on what factors resistance depends. Okay, so now we are moving on to the next section, that is known as combination of resistors. Because in a circuit, this is an electric circuit. So in a circuit, numerous number of resistors can be present. So basically we are interested in finding combination of resistors, or I can say if many resistors are given to you. If many resistors are given to you in a circuit, and if I want to replace all the resistors with a single resistor, yes or no? If I want to replace all the resistors with a single resistors whose effect will be equal to the combined effect of all the resistors, so then that single resistance will be known as equivalent resistance of the circuit. Getting my point? So if numerous number of more than one resistors are given to you and you want to replace all the resistors with a single resistor, yeah, you want to replace all the resistors with a single resistors whose property is equal to the combined effect of all these individual resistors. So that is known as equivalent resistance. So what I am doing, I am seeing two combination of resistors. One is series. There are basically two combination. One is series, another one is parallel. We will learn later. So first we are going to see series combination of resistors. So what is the basic property of series resistance is that if you can see in this diagram, carefully observe in this diagram, red dot is here. So that red dot is showing the direction of current. This red dot is showing the direction of current, and if you can see, this red rod is passing equally to all the resistors. Yes, you can observe this red dot is passing equally to the all the three resistors having resistance R1, R2 and R3. So this is basically a circuit diagram. This is basically a circuit diagram having three resistors R1, R2, R3 and a battery of potential difference V, and the current flowing is I. So what I want to do, I want to replace this circuit. Like this. This is V. This is a single resistance. The current is I. Okay, so this is equivalent resistance is this. This is the meaning of equivalent resistance, that you want to replace all the resistors with a single resistors, that is R equivalent. So series combination is that combination in which equal current passes through all the resistors. If you can see, whatever current is traveling through R1 will also travel through R2 and will also travel through R3. You can see from this ball. So this ball or this charge is finding only one direction for the flow. Yes or no? That's why equal amount of current will flow in the all resistors. So the basic property of series combination is that in series combination, equal current passes through each resistor. So there is no partiality in series combination. If I suppose say 2 ampere of current is passing through resistance R1, then that 2 ampere will also pass through R2 and that 2 ampere will also pass through R3 resistors. So that is known as series combination of resistors. So whenever series combination is present, what is the equivalent resistance? Equivalent resistance is the algebraic sum of all the resistors. Yeah, I'm talking about general formula. If there are n number of resistors, I'll simply add all these resistors like this, R1 plus R2 plus R3 up to Rn. So this is the equivalent combination of resistors in series combination. This is the formula for equivalent resistance of all the resistors in a series combination. What you have to do? First, you have to identify series combination in the question. How can you identify? If you move along the circuit, and same current is passing through any number of resistors, yeah. If same current is passing through any number of resistors, then all those resistors will be said to be in series combination. And in series combination, the equivalent resistance is equal to the algebraic sum of the resistance of individual resistors. Point is clear? So this is how series combination works. The basic trick to identify series combination is that just check the direction of current. Yeah. Well, or I can say the number of directions of current possible for a current to flow. Yeah. If there is only one direction possible for the current to flow, then that will be known as series combination. Okay. Now what we are interested in second type of combination, which is known as parallel combination. So second type of combination of resistors is the parallel combination. So what is the basic difference between series and parallel combinations? If you can see, if I mark this point as A, and I mark this point as B. So if you see, the current starts flowing from the battery, and if you know, the current always starts from positive terminal of the battery and terminates at the negative potential or negative terminal. So basically this is the direction of current. So when this current from the battery reaches point A, now there are three directions possible for this current to flow, yes or no? One is this one, second one is middle branch, and third one is lower branch. So whenever, what was their case in the series combination, that only one path was possible for the current to flow. Yes or no? Only one single path was possible for the current to flow. But what is happening in parallel combination? You can see there are more than one path available. There are more than one path available for the current to flow. You can see there are three paths available. So whenever this situation arises that current has more than one path available to flow, then this is known as parallel combination of resistors. So all these three resistors will be in parallel combination. Why? Because at junction A or at point A, there were three directions possible for the current to flow. Then that three directions will be set to be in parallel combination. Then that three directions will set to be in parallel combination. Thing is clear? So the equivalent resistance for parallel combination is given by 1 or by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3. And if I make a general formula, if there are n number of resistors present in parallel, the equivalent resistance will be like this: 1 by R1 plus 1 by R2 plus 1 by R3 up to 1 by Rn, nth number of resistors. Okay, so can I say the equivalent resistance or the reciprocal of the equivalent resistance? 1 by R equivalent means reciprocal. Yes or no? So the reciprocal of equivalent resistance in a parallel combination is equal to the sum of the reciprocal of individual resistance. Yes or no? Yes or no? Sum of the reciprocal of individual resistances. So 1 by R1 plus 1 by R2 plus 1 by R3 and 1 by Rn. So I hope this is clear. And there is one short trick also available. There is one short trick also available for the calculation of resistance. Short trick. So what is basically the short trick available is that suppose you are having two resistors. Suppose you are having two resistors like this. This trick is valid for two resistors only. Two resistors only. Not more than two, not less than two. Two resistors only. So now you can see this is a battery. This is the current. Suppose this is R1, this is R2. So now you can see R1 and R2 are in parallel combination, yes or no? Because at junction A, there are two paths of current possible. So these two are in parallel combination. So for two resistors, I can directly write the equivalent resistance as multiplication by addition. The trick is multiplication over addition. Multiplication means multiplication of the two resistors you are interested to find the equivalent of. So multiplication of resistance divided by addition. That means R1 plus R2. So without writing the reciprocal equation for the two resistors, we can directly use this relation as a short trick. Although this is a time saving trick, that's why I'm saying it as a short trick. Clear? That's why I'm saying it as a short trick. So R equivalent equals to multiplication over addition. Multiplication over addition. And remember, this trick is only valid for two resistors only. This trick is valid for only two resistors, not more than two, not less than two. Clear? So you can see parallel combination is also clear. So in series combination, what was constant? The current through each resistor was constant. The current through each resistor was constant. So what is the difference between series and parallel combination then? In parallel combination, what can you observe in parallel combination is that the current is not constant in all the branches. It was I1, I2 and I3. So in parallel combination, current is not constant as it was in the case of series combination. So what is then constant? If you can see, A and B are common point for all the branches, yes or no? Starting point is A and finishing point is B for all the three branches. I'm talking about all the three branches. So the initial and final point for all the three branches is same. And what is the potential difference between these branches? This will be given by VA minus VB. That means the difference between the potentials of point A and potential of point B. So can I say this A and B point are common to all the three branches, yes or no? This A and B are the common initial point and common final point for all the three branches. That's why they will be equal. That's why they will be equal. So can I say in parallel combination, potential difference is not constant. Sorry, I have written it wrong. Potential difference is constant. Yeah, by my mistake. Potential difference is constant. Okay. So what is the conclusion in series combination? Current is constant through every resistor, and in parallel combination, potential difference is constant through every resistor. Potential difference is constant through every resistor. So this is the basic bifurcation between series combination and parallel combination. And what is the equivalent resistance in series combination? It is just the algebraic sum of all the individual resistances. So I can say R equivalent is equals to R1 plus R2 plus R3 up to Rn. Okay. And what about parallel combination? It is equals to the reciprocal, yeah, sum of reciprocals of individual resistances. So that will be 1 by R equivalent. 1 by R equivalent is equals to 1 by R1 plus 1 by R2 up to 1 by Rn, nth number of resistor. That is clear? Okay, fine. Thumbs up, guys. Yeah, enjoying the session. So I have slowly and deeply explained all the concepts regarding Ohm's law, factors on which the resistance is depending, as well as the combination of resistors, that is series and parallel combination. So now we are going to do some numericals. Yeah, we are going to do some numericals on the applications of combination of resistors, what we have learned till now. Is this in clear? Yeah, ready to go? Yeah, now we are good to go in the question part. Yeah, ready, guys? Now see this question. Oh my God. Good question. Yeah, good network of resistors. How many resistors are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh my God. Sir, you have started with more than 2. Now you are done directly talking about 10 resistors. Okay, oh my God, this is so puzzled. I am puzzled, yeah. You are also puzzled? Yeah, I am also puzzled by observing this question. Oh my God, yeah. But we are left with no choice. We have to solve this, yeah. Okay, so now go with the trick. What was the trick? That to identify series combination, the trick is that the same current should flow through all the resistors. So whenever you want to find the equivalent resistance between 2 points, never start with the initial network. Always start with the final network and then move towards the point. What I'm saying, if you want to find the equivalent resistance between A and B, try to start from the far away points, then move towards AB point. Okay, so that is the basic flow of solving these questions. So if you can observe this R8 and R10, if you can observe this R8 and R10, what you are observing? Yes, this is R8, this is R10. Can you observe this? Can I say this R8 and R10 are in series? If you can see, the same current is flowing through them. Whatever current was flowing through R8 is the same current flowing through R10 also. So can I say these two are in series? Can I say these two are in series? Yes or no? Agree? So these two are in series. So what will be the equivalent resistance? And you know what is the equivalent resistance in series? Algebraic sum. So it will be 10 plus 2, that is 12 Newton. Oh, 12 ohm. So I can replace these two resistors with a single resistor of 12 ohm. Yes or no? So let's make the equivalent network. What can we make? The resistor was like this. This was A, this was B, this was 6, this was 8, yeah, 4, 8, 4. This was 4, this is 8, this is 4, 4, 8, 4. Okay, this is 6. Okay, this was 6, this was 8, this was 6, this was 8, and we have to replace two resistance with a single resistor 12 ohm. Yes or no? This is the new resistor 10 plus 2. Yeah, 10 plus 2 will give you 12. Now clear? Now if you carefully observe this 12 resistor, if you can see this point, from this point, this 12 ohm resistor and this 6 ohm resistors. Can I say these are in parallel? Can I say these are in parallel? If you carefully observe, guys, carefully try to observe. If you want to observe from this junction, one is this one, another one is this one. So these two are in parallel if you can observe. because both of them have same initial and final points, but the current is dividing. Current is dividing differently. So what is the parallel combination of 12 and 6? What is the parallel combination of 12 and 6? I already told you multiplication by addition. For two resistors, the trick is multiplication by addition. So it will be 12 into 6 divided by 12 plus 6, which is 18. So 6 3s are 18, 3 4s are 12. So this will be 4 ohm. So I can replace these two resistors with the equivalent resistance of 4 ohm. Yes or no? So now I'll redraw this circuit. Yeah, this is A, this is B. If you go step by step, there will be no difficulty. Yeah, the thing is that your concept should be crystal clear. This is 4, 6, 8, 4. I'm replacing this 12 and 6 with a single resistor of 4 ohm. This is now 4 ohm. This is again 8. So now if you again see, what are you again observing? This 4 ohm and this 8 ohm. These are in series, yes or no? These are in series. If you carefully see, same current is flowing through them, 4 as well as 8. So the equivalent of 4 and 8 will be 8 plus 4, that is 12. Yes or no? So I can replace these resistors with a resistor 12 ohm. 12 ohm. So what can I do? I'll do this like this. This is 4, 6, 8, 4, 8, 6, and this 8 and 4 are replaced by a single resistor of 12. Yes or no? Now if you again see these 12 and 6 are in parallel, yes or no? Much complicated, yeah? But if you go step by step, it will not be much more difficult. So these 12 and 6 are again in parallel. And if we have already calculated the resistor, equivalent resistance of 12 and 6 here. 12 into 6 divided by 12 with 6, which will be 4. So I can directly replace these resistors with a new resistor of 4 ohm. Yes or no? I can directly replace these two resistors with a new resistor of 4 ohm. This is already 4. This equivalent resistance of 6 and 12 will be 4. This was 8. This was 4. This was 8. This was 6. So this is the final. Now if you again observe, this 4 and 4 are in series. Yes or no? This 4 and 4 ohm are in series. So I can replace 4 and 4 ohm with the equivalent resistance of 8 ohm. Yes or no? They are in series. So equivalent resistance will be 4 plus 4, that is 8. So I can replace this like this. This is A, this is B. Okay. This was again 8. I can see. Yeah. This was 8. 4 plus 4 plus will give you 8. This was 4. This was 8. This was 6 and this was 8. Okay. Now if you again see, this 8 and 8 are in parallel. So what is the parallel combination of 8 and 8? Again, short trick, multiplication by addition. So 64 by 16, that will give you 4 ohm. So these two will again be replaced by a single resistance of 4 ohm. Okay. I am trying to explain that. If you solve it in an examination, it will not take much time. So this 8 and 8 are replaced by a single resistance of 4. Again 6, again 6, again 8. Yeah. Now these 4 and 4 are in series. So equivalent resistance will be 8. 4 plus 4 plus will give you 8. So the system will be like this. 6, 8, and equivalent of 4 and 4 is 8. This is A, this is B. Now again the equivalent resistance of 8 and 8 we have already calculated, that is 4. So I can replace this circuit now like this. This is 6, equivalent of 8 and 8 in parallel will give you 4. This is A, this is B. Now only two resistors are remaining, 6 and 4. And now it is very much easier for you. Yeah? You have started from the higher level, so this is much easier for you. That 6 plus 4 is in series. 6 plus 4 is in series. So the equivalent resistance will be 6 plus 4. Equivalent resistance will be 6 plus 4. Yes or no? So 6 plus 4 will give you 10. So now this is the final scenario. This is A, this is B. 6 plus 4 is 10. So by starting from a very bigger network, we have started traveling from the farthest point and we have moved into the inverts towards A and B and got the final result as 10 ohm. So the basic funda should be clear in your mind how to decide which is series, which is parallel combination. Whenever only one direction is present for a current to flow, that is known as series combination. And when more than one directions are able or are available for the flow of current, that is known as a parallel combination. The thing is clear? Okay, I think now we are sorted. Okay, now the next question. Find the current across each of the resistance. Now we have to find the current. What is given? Potential is given, resistance is given. Suppose this is the symbol of battery. This is positive, this is negative terminal. The bigger line or larger line will represent positive and smaller represents negative terminal. So, and I already told you current starts from positive. So this is the total current I. So first we have to calculate what is the total current flowing. So for that total current, you have to find the equivalent resistance first. So if you can see, this 5 ohm and 3 ohm are in series, yes. Only a single current can flow through these two resistors, yes or no? So these two are in series. So what is the equivalent resistance of 5 and 3 in series? It will be directly 5 plus 3. It will be directly 5 plus 3, that is 8 ohm. Yeah, in series combination, resistance are R1 plus R2 plus R3. So now if you can see, this 8 ohm and 8 ohm are in parallel, yes or no? This 8 ohm and 8 ohm are in parallel, yes or no? 8 ohm and 8 ohm. So what is the parallel combination of 8 ohm and 8 ohm? Multiplication by addition. 64 over 16, that will give you 4 ohm. So the equivalent resistance of the circuit is 4 ohm. See how quickly I have calculated. How quickly I have calculated this. This is 24 volts. This is 4 ohm. Now from the Ohm's law, now comes the application of Ohm's law, that V equals to IR. What is the potential difference given here? 24. What is the current? We have to calculate what is the resistance? 4 ohm. So if you solve this, you will get I equals to 6 ampere. So the total current from the battery will be 6 ampere. This will be 6 ampere. Okay. This will be again 6 ampere. So the total current flowing or starting from the battery is 6 ampere. That is clear. Now what we want to do, we want to calculate current across each resistance. We want to calculate current across each resistance. So that makes the question more complicated. Yes or no? That makes the question more complicated. So what you want to do, suppose this was current I. Suppose in this branch I1 current goes, in this branch I2 current goes. Yes or no? In this branch I1 current goes and in this branch I2 current goes. Can I say these two branches are in parallel combination? If I make this type of circuit, 8 ohm and 8 ohm. So if this was I current, this one was I1, this one was I2. And you know in parallel combination what is constant? Potential difference. So for this branch, can I write potential difference V is equals to current I2 into resistance 8 according to Ohm's law. Potential difference equals to current into resistor. And in this branch, the potential difference is V. Why? Because these two branches are in parallel and we already know in parallel combination potential difference is same. So can I write V as I1 into 8 because the combined resistance is 8 here. Yes or no? So can I say this, if I divide this equation, it will be 8 by 8 and 8 will get cancelled out. V and V will get cancelled out. You will get I1 equals to I2. So what does that mean? That equal current will divide into two branches. Equal current will divide into two branches. What was the total current? 6 ampere. So from that 6 ampere, 3 ampere will go in this branch and the remaining equal 3 ampere will go in this branch. Yeah. So we can see the current through each resistor will be 3 ampere. From 8 ohm it is 3 ampere. From 3 ohm it is 3 ampere. From 5 ohm it is 3 ampere. So that is the thing. That the current through each resistor is same. The thing is clear? Yeah. Done? Okay. Now I think the concept of Ohm's law is clear and how to calculate the combination of resistances. We have done a big numerical on this, which was consisting of the combined series and parallel combination. Yeah. So I think that must have cleared your all doubts. Yes or no? That must have cleared your all doubts, I must say. Okay. Done. Now moving on to the next one. Yeah, there are basically 4 types of question here. Yeah, there are basically 4 questions present here. So you'll quickly solve all of these. Again, this is a combination of series and parallel. Now in the first part, if you see directly from A to B, you have to calculate equivalent resistance between A and B in each of the cases. So if you see, if I started moving from A to B, the same current is flowing through all the resistors, yes or no? The same current is flowing through all the resistors if you carefully observe. Can you observe? The same current is flowing through all resistors, or I can say the path available to current is only one. So if there is only one path available to current, that is known as the series combination. So for series combination, your answer should be directly R1 plus R2 plus R3. So the equivalent resistance between A and B will be R1 plus R2 plus R3. As simple as that. The basic important thing is that you must know how to analyze series and parallel combination or how to identify them. Okay. Now if you see carefully this second one, Can I say this R3 and R4 are in series? Yeah, same current is flowing through them. And these two are in parallel with R2 because through this junction B, suppose I name this junction as C. So at junction C, there are two options available for current, one through R2 or one through R3. So these two branches are in parallel. So first you have to bifurcate these two R3 and R4. What we can do in second part, this is A, this is R1. For R3 and R4, I can replace with the equivalent resistance of R3 plus R4. Yes or no? Why? This was R2, this was C, this is R3 plus R4 because they are in series combination. So I can directly write R3 plus R4. Now you can see R2 and R3 plus R4. These two resistances are in parallel. From the C junction you can see. What is the parallel combination? I already told you, multiplication over addition. Multiplication over addition. So this is the basically equivalent resistance. So I can replace these two combinations with the equivalent resistance of this. So this is R1. This was point A. What is the equivalent combination of these two resistors? It is a very bigger quantity like this. R2 into R3 plus R4 over R3 plus R2 plus R4. So now these two resistances, one is R1, second one is this bigger quantity. These two are in series. So you have to simply add them. You have to simply add them and get the answer. So I hope you are good to go do, or I can say you are good to do the calculation that R1 plus that this bigger quantity will give you the equivalent resistance between A and B. That is clear? Okay. Thank you. Now question number 3. Now if you can see directly, this is a pretty much simple question. Now we have developed so much aptitude that you can easily identify. If we started going from A, there are two paths available. So these two branches are in parallel. Now from R1, the same current is flowing through R2, yes or no? From R1, the same current is flowing through R2, and from R3, the same current is flowing through R4. So can I say R1 and R2 are in series and R3 and R4 are in series? Yes or no? So the situation is like this. This is R1, this is R2, this is R3, this is R4. The situation is like this. So these are in series, these are in series. So I can replace this as a equivalent circuit like this. The combination of R1 and R2 in series will give you R1 plus R2. The combination of R3 and R4 in series will give you R3 plus R4. This is A, this is B. So as these are in parallel, now you easily know the trick how to calculate the equivalent resistance in parallel. Multiplication R1 plus R2 into R3 plus R4, multiplication over addition. So we have to add all the resistances R1 plus R2 plus R3 plus R4. So this is the equivalent resistance of the circuit. This is the equivalent resistance of the circuit. So now I think you are like a pro. You are like a pro in this equivalent resistances questions. We have discussed all the every possible questions or every possible case. Now this is fourth part. The fourth part is like this. This was A. The resistance is here. Okay. R2 and R3. This is B. R3, R2, R1. Okay. Now this is a very good question because if you can see, this is a common point B. This is a common point B. So if I want to write the potential difference across R1, what are the initial and final points of R1? Can you say the initial and final points of resistance R1 are B only? So for this R1, what is the potential difference? VB minus VB. That means the potential of point B minus potential of point B. So it will be 0 because it is connected to the same point. This resistance R1 is connected to the same point. So I can say the initial and final points are same. So potential difference is 0. So according to Ohm's law, V equals to IR, if potential difference is 0, what will be the current? Current will be 0. If potential difference is 0, current will be 0. So there will be no current flowing through these resistors. So we will remove this resistor from the circuit. That was the important point in this question. Whenever the initial and final points of a branch of a resistor are same, then potential difference will be 0 because initial and final point are same. So there is no potential difference between a single point. Okay, so the only portion remaining to us is like this. This was A. This was B. This was R3. This was R2. Okay, this was the only case remaining to us. Done. Now this is very simple. Yeah, that was the important point in the question that you have to recognize, was that this R1 is not included in the calculation as its initial and final points are equal, so potential difference is 0. Now you can see the same current will flow through R2 and R3. So we can say they are in series. They are in series. So equivalent resistance between A and B will be R2 plus R3 simply. R2 plus R3 simply. Okay. Now I think every concept is clear. So what we have discussed today, two important topics: Ohm's law and combination of resistances. Ohm's law says current flowing through a conductor is directly proportional to the potential difference between the 2 points of a conductor. And to remove the proportionality constant, we have to apply a resistance, a constant of proportionality, which is known as resistance of the conductor. Then we saw resistance depend upon three things: material of the conductor, length of the conductor, and cross-sectional area of the conductor. If you increase the length of the conductor, resistance increases. If you increase the cross-sectional area, resistance decreases, and vice versa. Okay, and resistivity is the material of the, or I can say resistivity is the property of the material of the conductor. Then we discuss series and parallel combination. Series combination is that combination in which current can flow through only one direction. That is R equals to R1 plus R2 plus R3 and so on. In parallel combination, there are more than one path available for current to flow. So in parallel combination, it was 1 by R equivalent equals to 1 by R1 plus 1 by R2 and so on. Okay. And also we have discussed the every possible question. We have started from the highest level question. There we have consists of basically 10 number of resistors. Yeah. So we have bifurcated that what is series, what is parallel. So if you are easily able to bifurcate or observe that what is series combination, what is parallel combination, then you can easily do the numericals, all numericals involved. Okay. So I hope every concept from today's class is clear. So I hope you enjoyed the lecture. You enjoyed every concept of this lecture. Yes. So in case of any doubt till now, or I can say in future, if you find any doubt, then you can refer to Ask IITians Doubt Forum. Yeah. There is Ask IITians Doubt Forum available on the Ask IITians website, where your doubts can be posted and it will be resolved by our experts. Okay. So I hope everything is clear today. So thank you so much, students. Stay safe and enjoy. Thank you.